Bismillahirrahmanirrahim. In this lecture, we are solving problem 6.7 from the book Applied Thermodynamics by McConkey. So, the statement of the problem is a mixture is made of 25% nitrogen, 35% oxygen, 20% carbon dioxide, and 20% carbon monoxide. This is basically carbon monoxide by volume. Calculate the molar mass of the mixture, molar heat capacities, Cp dash and Cv dash. Cp dash is molar heat capacity at constant pressure and Cv dash is molar heat capacity at constant volume. Gamma for the mixture, gamma is the ratio of specific heat capacities. Partial pressure of each constituent at pressure of 1.5 bar and density at pressure of 1.5 bar and temperature of 15 degrees centigrade. So in given data, first of all, volume fraction of nitrogen is equal to 25%, which is equal to 25 by 100, which is equal to 0.25, and we can write this volume fraction as mole fraction. Mole fraction, both are same. Mole fraction of nitrogen divided by total, this is mole fraction, is equal to 0.25. Similarly, volume fraction of oxygen is equal to 35%. 35 divided by 100 is equal to 0.35. So we can write volume fraction as mole fraction. Mole fraction of oxygen is equal to 0.35. Similarly, volume fraction of CO2 is equal to 20%. 20 means 20 divided by 100, which is equal to 0.20. So we can write volume fraction as mole fraction is equal to 0.20. Similarly, volume fraction of carbon monoxide is equal to 20%. 20% means 0.20. So this implies that mole fraction of CO, we can write volume fraction as mole fraction. Both are equal. So calculate the molar mass of the mixture. Required number 1, find molar mass. Number 2, molar heat capacities, Cp dash and Cv dash. Number 3, gamma, ratio of specific heat capacity. Number 4, partial pressure of each constituents. Pressure of nitrogen, pressure of oxygen, pressure of CO2 and pressure of CO. A total pressure is equal to 1.5 bar, and 1.5 bar is 1.5 multiplied by 10 power 5 Newton per square meter is Pascal. Number 5, find the density of the mixture at pressure of 1.5 bar and temperature as 15 degrees centigrade, and 15 degrees centigrade convert it to Kelvin. So this is equal to 15 plus 273 Kelvin. So T is equal to 288 Kelvin. And there are some constant values to remember. We know that molar mass of nitrogen is 28 kilogram per kilomole. Molar mass of oxygen is 32 kilogram per kilomole. Molar mass of carbon dioxide is 44 kilogram per kilomole. Molar mass of carbon monoxide is equal to 28 kilogram per kilomole. Similarly, molar specific heat constant Cp dash per nitrogen is equal to 29.124 kilojoule per kilomole per, you can write this joule per mole, both are correct. Cp dash per oxygen is equal to 29.37 kilojoule per kilomole per Kelvin. Similarly, molar specific heat constant at constant pressure per carbon dioxide is equal to 37.135 kilojoule per kilomole per Kelvin, and Cp dash per carbon monoxide is equal to 29.14 kilojoule per kilogram per kilomole per Kelvin. Now we will start solution. So in solution, first we find solution number 1, find molar mass. So formula for molar mass in the book is summation of, this is mole fraction, multiply by m dash I. So molar value is, there are 4 constituents: nitrogen, oxygen, carbon dioxide and carbon monoxide. So molar fraction of carbon dioxide, molar fraction of nitrogen, and molar mass multiply by molar mass of nitrogen, plus molar fraction of oxygen multiply by molar mass of oxygen, plus molar fraction of carbon dioxide multiply by molar mass of carbon dioxide, plus molar fraction of CO, carbon monoxide, multiply by molar mass of carbon monoxide. Now putting values to find molar mass. Molar fraction of nitrogen is 0.25, already explained in the given data. Molar mass of nitrogen is 28 kilogram per kilomole, plus molar fraction of oxygen is 0.35, multiply by molar mass of oxygen is 632 kilogram per kilomole, plus molar fraction of carbon dioxide is 0.20, molar mass of carbon dioxide is 44 kilogram per kilomole, plus molar fraction of carbon monoxide is 0.20 and molar mass of carbon monoxide is 28 kilogram per kilomole. So molar mass is 0.25 multiplied by 28 is equal to 7 kilogram per kilomole. 0.35 multiplied by 32 is 11.2 kilogram per kilomole. 0.20 multiplied by 44 is 8.8 kilogram per kilomole. 0.20 multiplied by 28 is 5.6 kilogram per kilomole. Now add these two all values. So molar mass is equal to 32.6 kilogram per kilomole. So this is the solution of the first question. Now to find Cp dash of the mixture, Cp dash for the mixture. So formula for Cp dash is equal to summation of molar fraction multiply by molar gas in summation means sum all the constituents. So Cp dash for the mixture is equal to summation of Ni divided by N, mean molar fraction of nitrogen divided by Cp dash per nitrogen, plus molar fraction of oxygen multiply by molar Cp per oxygen, plus molar fraction per carbon dioxide multiply by Cp dash per carbon dioxide plus molar fraction plus per carbon monoxide multiply by Cp dash per carbon monoxide. So Cp molar per mixture is equal to, putting values, molar fraction is 0.25 multiply by 37.135, sorry, 29.124. Cp dash per nitrogen is 29.124 kilojoule per kilomole per Kelvin, plus molar fraction of oxygen is 0.35 multiplied by Cp dash per oxygen is 29.376 kilojoule per kilomole per Kelvin, plus molar fraction per carbon dioxide is 0.20 and Cp dash per carbon dioxide is 37.135 kilojoule per kilomole per Kelvin, plus molar fraction per carbon dioxide 0.20 and molar and Cp dash is 29.14 kilojoule per kilomole per Kelvin. Now simplify the Cp dash per the mixture is equal to 0.25 multiplied by 29.124 is 7.281 kilojoule per kilomole per Kelvin, plus 0.35 multiplied by 29.376 is 10.2816 kilojoule per kilomole per Kelvin, plus 0.20 multiplied by 37.135 is 7.427 kilojoule per kilomole per Kelvin, and 0.20 multiplied by 29.14 is 5.828 kilojoule per kilomole per. Now add these to all values, so this will be the final value Cp of the mixture, which is 30.817 kilojoule per kilomole per Kelvin. Now we are finding Cv dash for the mixture. Cv dash for the mixture. So as we know that Cp minus Cv dash is equal to R dash. So Cv dash for the mixture, rearrange this equation, is equal to Cp dash for the mixture minus R dash, universal case constant. So Cv dash for the mixture is equal to 30.817 kilojoule per kilomole per Kelvin, minus the value of R is 8.314 kilojoule per kilomole per Kelvin. So Cv dash for the mixture is equal to 22.503 kilojoule per kilomole per Kelvin. Now part number 3. At part number 3, gamma is needed. So gamma is equal to Cp dash Cp divided by Cp dash divided by Cv dash. We can find this from Cp divided by Cv and also from Cp divided by Cv. So Cp dash divided by Cv dash is 30.87 kilojoule per kilomole per Kelvin divided by Cv dash is 22.503 kilojoule per kilomole per Kelvin. We can find gamma from Cp divided by Cv and also from Cp dash divided by Cv dash. So this is equal to 1.369 kilojoule per kilomole per Kelvin will be cancelled. So this is the value of gamma. Now to find the partial pressure of each constituent. So partial pressure of nitrogen is equal to molar fraction of nitrogen multiplied by total pressure. So molar fraction of nitrogen is 0.25 and total pressure is 1.5 bar. So pressure of nitrogen is equal to 0.375 bar. Similarly, partial pressure of oxygen is equal to molar fraction of oxygen multiplied by total pressure. So molar fraction of oxygen is 0.35 and partial pressure, total pressure of oxygen is 1.5 bar. So partial pressure of oxygen is 0.525 bar. Similarly, to find partial pressure of carbon dioxide, molar fraction or carbon dioxide multiplied by total pressure. Molar is 0.20 and total pressure is 1.5 bar. So pressure of carbon dioxide is equal to 0.3 bar. And finally, partial pressure of carbon monoxide is equal to molar fraction of carbon monoxide multiplied by total pressure, which is equal to 0.20 multiplied by 1.5 bar. So partial pressure of carbon monoxide is 0.3 bar. This is the solution of part number 4. And part number 5, we have to find density. So density is equal to pressure Pm dash divided by R dash T. Pm dash is equal to rho R dash T. So rearrange, so find density. So pressure is given to us as 1.5 bar or 1.5 multiplied by 10 power 5 Newton per square meter. Molar mass is 32.6 kilogram per kilo mole, and R dash is constant 8.3144 kilojoule. Joule is equal to Newton meter per kilomole per Kelvin multiplied by T is 288 Kelvin, which is given. Now this Kelvin will be cancelled with this Kelvin, kilomole will be cancelled with kilomole, and Newton will be cancelled with Newton. So rho will be equal to, first multiply these two and divide by these two values. So the answer will be 2042 and kilogram per kilo cubic meter. But we have need this value and kilogram per cubic meter. So this will be equal to 2042 kilogram per cubic meter, and this kilo is equal to 10,000. This kilo is equal to 1000. So rho is equal to 2042 divided by 1000 is 2.042 kilogram per cubic meter, and this is the final answer. If you have any problem in McConkey book or Sengel book or any other thermodynamic book, please share the problem with me. I will solve for you. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.